I have started. This is a lecture. Name of this lecture is in front of you. Is what quadratic equation. Standard is a 10th. Our focus will be on this discussion, and there will be all points, all topics of this lecture. We will go in depth. Don't worry. In details, we will try to understand this lecture. Topic wise. Topic wise. First point, you are crystal clear that this is our chapter. Now, we don't need to waste time. Let's start. Let's begin with what is a quadratic equation. Here we know that this is quadratic and this is equation. In an equation, there would be variable or variables. If a variable has 2 degree, so that equation will be quadratic equation. That is what we already know. But let's see what does it say. What is a mention in this about this quadratic equation? Let's see. In quadratic equation, we first of all we will understand this introduction to quadratic equation, then use of a quadratic equation, then factorization. So let's see this polynomial. Poly which means many, nomial which means level, many level. Polynomial which means there are a lot of equations, algebraic equation with a degree. First we have this 2x plus 4. 2x plus 4. Can we say that this is a polynomial? Yes, of course we can say. We can say this is a polynomial because it is an algebraic equation. Polynomial makes by adding, it forms itself by taking a variable or a coefficient number, or it can take what constant number. It can take a lot of variables. It can take a lot of constant numbers. Right now we have one coefficient number and one variable and one constant number, and here operators will also come. Don't worry, okay, operators will also come to form polynomial. In this we have two terms, this one, this is second. This would be one term, this would be third term. Here we are saying that whatever value we will put in x, so here it means we will put here x as any number. So this is the first polynomial, 2x plus 4. Now can we say this is a polynomial? Yes, of course this is polynomial. How to check? I will tell you. Right now I want to tell you. Any number here, degree should not be, it should be what, only whole number. Degree should be only whole number, not integer, not rational. Only whole number which starts from 0. It can go till the infinity. Okay. Here we can see in this degree is 1, exponent is 1. That's why it is valid for to be said polynomial. Now here what is happening? Here degree is a 2, exponent is a 2, and it's a vowel, it's a whole number, so that's why it is also valid. Just your focus should be on exponents to say that is this a given algebraic expression polynomial or not. Just your focus should be on the exponents of the variable. Here we have 2, here we have 1. So all these are whole numbers. Here all these are whole numbers. Now next we have here this is a 3 cubic. It is also considered as a cubic, and 2 is also considered as a quadratic. and why here is one hidden, one is hidden, one is a exponent over here, 2 is the exponent, over here 3 is the exponent. Here you can see y is containing 3 exponent, here y is containing 2, and here y is containing how much exponent? 1 exponent. All these are polynomial which are valid. Why? Because the whole exponents are whole, that's why. Okay, so all these are whole. Here you can see all these are this one, this two. There are two terms in this. In this there are three terms. 1, 2, 3, including operators. In this we have four terms. 1, 2, 3, 4. So this whole minus 9 is a whole one term, and this whole minus 3y is a one term. This plus 7y square is a whole one term. This yq is a whole term. Clear? And you know that this only 4 without any variable will be considered as a constant number, because it is a fixed. It is considered as a fixed number because there is no variable, and variable comes because we don't know. Variable is used to unknown number. Here x can be any number. That's why we are not saying that 2x is a fixed number. No, it's not fixed, because x can be any number. X can be 2, x can be 4, any number. And here 4 is a fixed. And remember, any number which is with variable will be considered as a coefficient number. Okay, in the next slide, all the algebraic expression. So here these are all algebraic expression, you can say. These are algebraic expression, or you can call it as a polynomial. Now all the algebraic expression in which the exponents of the variable is a whole is a polynomial. If all the variables in an algebraic expression are a whole number, then yeah, the given is a polynomial. Okay. In this you can see we have 0. Is this polynomial? I would say yes, this is polynomial. Is this polynomial? Yes, this is polynomial. Here we have 0 exponent. Here we have 0 exponent. In this we have also 0 exponent. In this we have a 1 exponent here, over here. In this we can easily see this is visible, this is a 2, and this is 1. And this whole is known as, this whole algebraic expression is known as quadratic equation, because highest exponent is a 2. Highest, I am talking about highest exponent. In this, the highest exponent is a 3. That's why this whole will be considered as a cubic polynomial. So yes, we can say all these are polynomials, including this. Based on degree, we can understand the types of polynomial. First we have zero polynomial. This is zero polynomial. Here we have this constant without any variable. So in this we have what? Also zero polynomial. In this, here 1, degree is 1. That's why it will be linear polynomial. Here there are 2 exponents of a variable, so that's why this will be what? Quadratic polynomial. And here this cubic polynomial. Clear? It is zero polynomial because of here x raised to power 0 will give us 1. Then 0 multiple 1 will become 0. Here we have 2. Then we know that with this is hidden x raised to power 0. X raised to power 0 is a what? Is a 1. So 2 1s are 1 as it. But in this we have what? A constant number which is without variable. So in this lecture our focus will be on this quadratic equation where exponents would be 2. Here try to understand, we have a algebraic equation, not equation, algebraic expression. Algebraic equation, which means algebraic expression, which means without equal sign. Here you can say x plus y, then here 2. If we apply here plus between them, then it will become algebraic equation. Here this equal came here. Now this whole, right now it is what? Algebraic equation. When equal will come into picture, then this whole will become algebraic expression. This equation, algebraic equation. Okay, it is considered as equation. We are saying, by using this, we are saying that this LHS is equal to RHS. In this, how much variables do you have? Of course, you have two variables. So you can say linear pair in two variables. This is what? Linear pair, linear equation in two variables, because all this both variables are containing one variable. That's all. 1 degree, 1 exponent, you can say. Okay, here right now we have quadratic equation because of degrees, highest degree is 2. That's why we are saying. And quadratic equation looks like that. First 2 will come exponent, then 1 exponent will come, then 0 will come. That is how it is arranged. Now next here we have, it can be written as like that: x square plus 4x plus 4 is equal to 0. Now we are saying that this whole is equal to 0. And this is not quadratic equation, because equation is not added here, over here. That's why. So this whole will be polynomial but not a quadratic equation. Now this became quadratic equation when we added this equation, this equal sign. So this 2 is a determinant about quadratic equation. Here in this algebraic equation, you can see exponent is here, highest exponent is here, or 2, here 2, here 2, also here 2. So all this will be, and here you can see exponents are whole number. So that's why all this will be quadratic equation. It is already arranged. It can be arranged because it is not already arranged. This will come firstly, then this is secondly, then this is already third position. This will come firstly, this is already at the second position, this will come here, over here. That is how it is arranged. Highest exponent will come firstly, then low, then most low, then more low. Okay, all these are here. Remember, in general form, quadratic equation is expressed like that. Here a is a coefficient number, b is also coefficient number, and c is a constant number. But x both are variables. Okay. And here 2 exponent is how much? 2. That's why this whole is a quadratic equation. Because of exponent is 2. It is in general form to represent quadratic equation form. Yeah, we know that this is a quadratic equation. What else? Then here a, b, c are real numbers, and a should not be equal to 0. Yeah, when a will be equal to 0, then this whole will not be still what? Quadratic equation. Clear? So that's why it is saying that a should not be equal to 0. B can be equal to 0, c can be equal to 0, but a should not be equal to 0. Here in this we have 0, as we know that degree which means exponent, polynomial, then quadratic equation. What is happening over here? X square is equal to 0. Yeah, it is still quadratic equation. We can say that this is a still quadratic equation. Yeah, because highest, and we know that a should not be equal to 0. Here b, it can be written as x square plus 0b plus 0c, like that. Not 0c, only 0. It can be written as how x square then plus 0 y then plus 0 is equal to 0. Both will be same. That's why we are saying that this is only x square is a quadratic equation. But remember, only x square will not be quadratic equation. We will have to add this equal sign with a 0. Now this whole is a quadratic equation. Clear? Now in this, let's say ax raised to power 2 then plus b. Yeah. This is 2, 1 is hidden, and this x raised to power 0 is completely hidden. As we know that x raised to power is gives how much? 1. That's why c multiple 1 becomes c. Here we already know that a will not be equal to 0. Here is standard form of a quadratic equation. This is a standard form. Any equation you have already, okay. Now that equation is not arranged. You can arrange that equation in this form. We have some question. Check whether the following are quadratic equation or not. Here we can see that yes, exponents are 3. In this also are 3. Exponents are whole number. In this, yes, exponents are whole number, and in this, yes, exponents are whole number. All these are valid. All these are quadratic equation because of exponents are whole number. That's why. That's it. One rule is completed. One rule all these quadratic equations are following. This is for you. Yeah. Same here. You can see. Here what is happening? X plus 12 is equal to 0, which is not in the form, but it can be. Yeah. After simplifying, then here we don't have x square. That's why. Here we have this in this form. Then we will say that yes, given polynomial will be what? It should be quadratic equation. Now this is done. Next, use of quadratic equation. Quadratic equation. Okay. There is a one boy, there is a one girl. Name of this is John, name of this is Jayanti. Now here 45 are these objects. There are 45 objects. 5 objects. This 5 objects. Okay. Now including this is how much? 124. How much is this? So for this is x, and here for this is what? 40 minus x. Here we are saying that whatever he will get, we will subtract this by this 45. Then we will be able to know that she got this much objects. For example, x minus 5. Okay, and this wall is equal to 124. So x minus 5, then 40 minus x, then this is equal to 125. Just simplify it, and you will get this much. So this wall is a quadratic equation. Now here, look at here. Rohan's mother is 26 years older than him. 26 years older than him. It means age of Rohan is less than mother. Okay. The product of their age in years 3 years from now will be 360. Product of Rohan's age and mother's age will be how much? 360. So can we say 28, 26 multiple x? Hold on. Is how much? 26 years older than him. But after 3 years, in 3 years, okay, he would like to find Rohan's percentage. He would like to find Rohan's percentage. This is puzzle. X plus 26. We are considering this x for Rohan's age and x plus 3 after 3 years, and here we will add with this 26 plus 3. 26 plus 3, it will become 29. So here product of this and this would be this much. What is happening here? This is telling you that age of this is 26, and here this is 3 years old than percent. So we don't know percentage. So for percentage we entered x and plus 3. This is more. Now here okay, then here you can see we are getting quadratic equation. Now next let the percentage of Rohan x and his mother's age is how much? X plus 26. X plus 26. According to the equation, it will become this like that. X plus 3, then product of this and this is this much. Yeah. A train travels a distance of this much. A train travels a distance of 480 km at a uniform speed. If the speed had been 8 km per hour less, then it would have taken 3 hours more to cover the same distance. We needed to find the speed of the train. Here 480 km at uniform speed, 8 km less for less minus, and this was continued. And after 3 years more to cover the same distance. This is how you will solve it. Factorization. Let's see factorization. Sure. Solution. 2x minus 1 is giving us how much? 0. Yes, this is a solution. Why? Because it is giving something. Here x is equal to 1 by 2. But what about this? Is it solution? We are not able to find. So after simplifying out, then we will be able to find that yes, this is not solution or this is solution. First of all, you will have to simplify this. Then you can see here x, okay. When we enter x as our input as 1, then what is happening? We will start from 1. Okay, we will start from 1. We know that if we put here 0 0, then what will happen? This will become a 1 and 1 is equal to 0. Both are not equal. But what if we put here 1 and here 1? Will it this side become 0? Let's say 2 1 2, then here minus 3 1 3. 2 1 3, 3 minus 3, it became 0. So yes, both sides are 0. That's why if both sides are coming 0, then we can say that yeah, this is solution. If both sides are not coming 0, one side is getting 0 but another side is not getting 0, then this this would not be solution. Here we can see when we put 1 as ix, then this whole side is becoming 0. That's why this is a quadratic equation. Okay, 0. Now alpha root. Here we can say, here x is what? Alpha. X is what? Alpha. This variable is alpha. X is equal to alpha. Now we took 0, then root. 0, then root. What's the difference between them? Nothing. Yes, here it is not equal to 0. This is not equal to 0. This is equal to 0. Factorization by splitting middle term. That's the same. 2x square minus 5x plus 3 is equal to 0. Is equal to 0. Let's see. Will this side become 0? If yes, then we can say yes, we have a solution for this. But no, then we can say there is no solution for this. How much should we put here? X as how much? I think 4. 2 to the 4, then 4 to the 8 minus. But hold up, there is also 2. So 5 to the 10. No. Here b is what? B is r or q. R comma q. I think it should be remainder or quotient. R plus q gives you a c. Minus 5. Yeah, now I understood. You see, it is telling you that here what is happening in this remainder plus quotient, when both will be added, then this will be equal to this, which means when this will be added, then this will be equal to product of this a and c. Same here you can see 2 3 is 6, it is becoming 6, but sum of this should be how much? 6. Should be how much? Minus product is how much? 3 2 is 6, but sum is how much? Minus 5. This is known as a splitting method. This is known as a splitting method. Here it is telling you sum of what is that product that will give us minus 5. So product is what? Minus 2 and minus 3. We know that this will give us minus 5. But this should be how much? By multiplying it should come 6. As you can see, 3 2 is 6. That's why these are values for this. Now we will write this as minus 2x plus minus 3x. Just we are splitting, nothing else. Here you can see the product of this is giving how much? 6. And here we know that this multiple this becomes 6. Here 2x square minus 2x minus 3x. Now it became like that. We here applied whatever we wanted to apply. What is happening here over? Here we know that 2 is common. As you can see, as well as x is also common in these two terms. I am talking about in this two term. So 2x is a common. So 2x will be taken as a common, and here we will left x minus 1. How to prove? Just here you can see carefully. 2x multiple x, it is becoming 2x square. Then minus as it, then 2x multiple 1, it is becoming 2x. Minus as it, then here 3 multiple x, it is becoming minus 3x, because we have here minus, here minus. So we know that minus minus will become plus. Then here 3 1 3. Yeah, that's why this is correct. We have proved. Now here, whatever will be outside the terms will be written in one bracket, and whatever will be common in bracket uh, will be written in another bracket. As you can see here, we have these terms which are outside. So 2x minus 3, it is written inside the one bracket. Now this x minus 1, this x minus 1, both are common, so both will be taken as a common. So we wrote here. Now we will separate this. We will write like that: x minus 1 is equal to 0, then 2x minus 3 is equal to 0. By doing like that, we will get two zeros. We will get two values of x. Here you can see. Like that we will do. Then after simplifying it, we will get x as a 1 and then x as a 3 upon 2. So these are two solutions of this. These are two solutions of this. Just by using a splitting method, we found two zeros of this polynomial, of this quadratic equation. There are more methods to find out zeros of a quadratic equation. We will use that method, don't worry. Okay, till here we are clear. Example. Now what about this? Is it hard? What about this? Is it hard? First of all, this is a quadratic equation, because here x is not in under root, 6 is in under root. Okay? As you know that value of under root is what? 1 upon 2, half. But here main point is that x is not in under root. Now let's simplify it. We know that this will become 3 to the 6. But what would be that product which will give us 2 under root of the 6? What would be? So 3 to the 6. 3 to the 6. So here it should be minus 6 will become 12. 6 to the 12. Oh, minus 6. This is product of this. Just we will use this. And 6 6 are 36. Yes, it is become 6. Now just we applied this root 6x minus root 6x. Now further of it, we will simplify it. Then we will get two zeros. One is this under root of 2 upon 3, and second is both are same. And both are rational number or real number or real. Both are real number. These three are done. Now let's see next. We have some questions. Right now we have some questions. The altitude of a right angle is 7 centimeter less than its base. Okay, so we can say base is x and altitude is 7. Altitude is 7. but altitude is just 7 centimeter less. Can we say that x base x and altitude x minus 7? If the hypotenuse is a 13 centimeter, then find the other two sides. So first would be x and second would be x minus 7. X minus 7, then we know that x minus 7 square plus x x square then is equal to 13 centimeter square. Here we are familiar with this. This is altitude, which is perpendicular, this is base, and this is hypotenuse. And here we are saying x minus 7, and this we will take this as a x. Now a square of this plus a square of this will be equal to a square of this. This is what is a Pythagoras theorem. Here you can see. Now just we will substitute value of each and then we will solve it. Okay, as you can see what is happening. We are getting two zeros, x has a 12 and x has a minus 5. Here we are saying meaning of this answer is that it is saying that if you put a 12 then you will get a base, for example base, or if you put minus 5 then you will get base, but minus 5 is not. Why minus 5? Base is how much? 12. When we will put minus 5 then our sum will not come as a 13, that's why. So rather than taking minus 5 you can take 12 if 12 is giving equal to 13. Then altitude, now it is becoming how much after putting value of x as a 12, then it is altitude is giving how much? 5. So here we can say 12 plus 5 is becoming 17 and it is equal to hypotenuse. Now next we have it is for you. What happened? Is it done? Yes, this is done. Now next slide, next chapter, let's take next chapter. Solution of quadratic equation completing a square. Let's let's have a look over here. X plus, yeah, we know that this is here we will apply algebraic identities because it is giving opportunity to apply algebraic identities. Here it is what? A plus b as raised to power 2. That's why. So after applying algebraic identities, then just see that what is coming. So here we applied algebraic identities and here at the end we are getting this two values of x. First is minus 5 and second is 1. If you put minus 5 in this, then what will happen? Minus 5, then it will become 25, then here 20. So it will become 29 and 33. What is happening? So I think here should be 1. 1 plus 4, 4 and 4. 1 plus 4, 4, 4, 8 and 1. 9. 9 minus 9 is giving how much? it is giving 0. Yeah, so 1 is we can put here 1. If we put minus 5, then what will happen? So 25 minus 5, it will become 20. But hold on, 20. So here minus 5, we put here minus, it will become minus, but it will become 20. And here this is how much? 25. 25 minus 20. 5. 5 plus 9. Yes, both are working. Both are working. 9 minus 9 will be 0. You can put both one by one. Both are working. Now we can say these are two solutions of this. And here we did factor. We did factor here. You can see. Just by using algebraic identities. Now next. Factorization. No. Okay. Okay. This side it is a 9. Then. Oh. Just under root. Without using algebraic identities, we can solve like that. Just like that, and then it will cut this. And here. This will be as it. We know that 3 3 is a 9. Okay. X plus 2. And we can see here it is giving us how much? Plus 5 and minus 1. Yeah, like that it can be solved. Just by using, because here 9 is a perfect square of 3. That's why. Yeah, done. Done, okay. Okay, done. Okay, x plus 2. Okay. Factorization. No, why? Now what about this? X square minus 9. Here we can see that 9 is a perfect square of 3. And we know that x square, a square minus b square, it becomes a plus b inside the bracket, then a minus b. So a is a x and b is a 3. So 3 plus x plus 3, then x minus 3. Here you can see. This will come this side, and then just we will apply root. Then root underscore will cut, and here we will get 9 in under root. Then it will come like that, 3 plus 1 plus minus 3. Here we are saying x is as a plus 3, and second is what? X as a minus 3, because here we had root 3 was inside the root. That's why we are here, we have plus 3 as well as minus 3. This is known as root is final. Zeros are root. We got here 2 roots. This is another method, and here this is another method. And in both method we are getting same answer. Solution of a quadratic equation by completing the square. Method of completing the squares. Okay. Here x square plus 4x. We know that 4 is the perfect square of 2. 2. Yeah. Now it is becoming this much, and both are equal to each other. What about this? X plus a raised to power 2 minus b is equal to a. a square rectangle. We know that a square gives us this is side square and a rectangle base multiple height. Okay, so here we are giving what x square, so that's why it is what base multiple height. So x, okay, and this is 4. Okay, here x square, then here 4x, x square plus 4x. It can be written as x square plus 4x. Okay, both are equally. Yeah. Yes. Then what else? It is 2 and x plus 2, like that, and whole become this much. I know what is happening. Here we have just a project. It is a x square, then plus 2 raised to power 2, and then minus 2ab. Here one identity is coming mathematical form. Yeah, this is becoming this much. This is becoming. We are continuing. We were here. Let's move ahead. We know that 4x can be written as a 2 multiple 2. Here we 2 is what? We are taking x as a and 2 as a b. Okay, as a b. This is for you. I want to move. A square plus 2ab plus b square. Okay. This is done. This is for you. I hope it will be done by you. You are already familiar that this is equal to this, because this is algebraic identity. Same this was applied on this. Here 2 square. It is what? Just a value of b. This is the value of b. Now method of completing the square. Wow. I don't think so that it is new for me. X square minus 6. 3 to the 6. So x minus 3. Then minus 2x. Minus 6x. X minus 3 raised to power and then minus 9. 3x raised to power 2 minus 5x plus 2 is equal to 0. We have quadratic equation. Okay, let's simplify it. Here we are going to use this formula: x plus a raised to power this, then minus b. Solution is that here this is b, we are taking this b. X square plus 4x is equal to 0. X square minus 6x is equal to 0. X square minus 6x is equal to 0. I am leaving it for you. Okay, you do this 3x raised to power 2, then here let's divide this by 3, then it will become like that. Just we divided in this by 3 and here in this side by 3, it is looking like that. Okay, then what else? Yeah, a is equal to x and b is equal to 5 upon 6, 5 upon 6. 5 upon 6. This is for you, this is for you. Whatever will come zeros of the quadratic equation will be root. This 0 will be also known as root of root. This is for you, brother. This is for you. This is for you. Next we have quadratic geometry. Let's explore it. What is inside it? Distance formula need of quadratic equation. This is out of this. Can you measure the area of your classroom? Area, not length. If you are given an inch tape, by finding the length and breadth of the classroom, you can easily find its area. Yes, find its area. And if I say you have to find the area of your school, then what will you use? Yes, it can also be known with the help of measuring tape. Now if I tell that you have to measure the area of your village, city, state, or if you have to find the distance between two villages, then what will you do in that case? I think in this case you will not be able to use type. Now you cannot measure it with the help of a measuring tape, then what you will do? Just you will locate a position. Let us try to understand coordinate geometry with the help of an example. In such situation where we have to find the distance between two places or to find the area of any large field, we use coordinate geometry. Use of a coordinate geometry is what? We use coordinate geometry so that we can find the distance between two things where we cannot use a tape. Let us try to understand coordinate geometry. Okay, let's try to understand. Introduction of a coordinate geometry. We are starting this with the introduction of a coordinate geometry. First situation. We can find location of anything by just coordinate geometry, by just using this. For example, this is address of somebody and this is address of somebody else. From here to tell your total length distance is becoming how much? 7 centimeter. But this will come out and then it will go to tell you, then it will go this side. What if there is a person who don't know address of this and you will have to tell, then what will you say to this person, you will say to this person that yes, just to go this 4 kilometer, just cover this 4 kilometer instead. Then after covering 4 kilometer distance, then turn this side, then cover 3 kilometer, then you will reach to the this address. That is what you will say. And this is how we are saying that address of this, you will go to this address. That is how we are explaining address of this to a person. But we here who try to understand this is total 3 including 3 and 4. When we add both, then it is giving what? Total length. But what is the shortest distance? We know that there is no road, but shortest distance between them is what short and less as compared to this distance. This shortest is what displacement. The shortest is a displacement. Now, if you are asked that what would be the distance between Joy and Viru's house? What would be the distance? So distance would be 7, but displacement would be, we will have to find out. So how can we calculate this displacement? Just add this with this, then sum of this both will give us this displacement. You might be thinking that it is very easy, take a measuring tape and measure them, but no, it's not like that. Assuming that by doing so we can find the distance between their homes. Second situation. Now if you are told that a river is flowing in the middle of the path of Ajay and Veru's house, and you have to find the distance between their homes, then what will you do? Now in that case, what will happen? Let's say in such a situation, you cannot measure the distance from the tip by going into river. Then what will be the right things to do, to use? Have you seen the picture where this picture? It is very risky. If we go in this river, then it will be very risky. Without taking risk, we can find the distance between two houses. But how? Question is how? Have you seen the picture? Yes. Let's see. That is the shortest. Now, after seeing this picture, we find that a right triangle. Yes, this right triangle is formed in between the school, Joy's house, and Veru's house. Which the two sides? Which the two sides are known? And we have to find hypotenuse. Yes, just we can use here Pythagoras theorem. Just by using Pythagoras theorem, you will get what this h, and we know that this is a p, this is a b, and here we can use Pythagoras theorem. After finding this hypotenuse by using Pythagoras theorem, you will get this distance. This is not a distance, it will be hypotenuse is just displacement. Okay, hypotenuse is just displacement. So we can find the hypotenuse by using Pythagoras, and we did it. Okay, according to Pythagoras, we have done. And here answer is coming how much? Answer will come 3 3 is 9 4 4 is 16 25. So not 25, only 5 centimeter. And here displacement is less than total length. Total length is 7, which is more. C is hypotenuse, A is perpendicular, B is a base. You are already aware of it. So hypotenuse is coming as a 5. Third situation, suppose your school was discharged. Your school was discharged and Joy and Virus went to their own home. Own home. Here. A school is where? This is Mandir and this is river. This is Virus house and this is Jaya house. But where is the school? From his home, Jay went for playing in a park towards 1 kilometer east. 1 kilometer east from his house, and Virus went to a temple which is 1 kilometer north of his house. A river is flowing between the park and the temple. Here, between this. This is talking about this. This is a distance. How to calculate this distance? Now, if you have to find the distance between Jaya and Viru, then what you will do? Here neither we can measure the distance from measuring tape, nor use the Pythagoras theorem, because there is no option to use Pythagoras theorem. Then what can be the way? In order to solve such kind of a problem, it is very important for us to have knowledge of coordinate geometry. I think we did not start. I think so. Yeah. So before knowing its a solution, let's revise some concept of coordinate geometry in the next video. Okay, let's see. Yeah, it is important to have knowledge regarding coordinate geometry so that we can find any location, any address. Revision of a coordinate geometry. We know that we can form this horizontal is x-axis and this vertical is a y-axis. But from this 0, this is left side, this right side, it is what? Plus x, positive x, and this side negative x. This side positive y, and this side negative y. This is what coordinate geometry. Not this is coordinate geometry. This is what xy plane. Coordinate would be what? X comma y. Coordinate would be what? X comma y. Perpendicular distance of a point from the y-axis is called abscissa. This perpendicular will be what? Abscissa, or the x coordinate of that point. This is x axis, called the ordinate or y coordinate of that. So x axis. This x axis will be ordinate, but this y axis would be abscissa. Y axis is called abscissa, but x axis is called ordinate. To represent any point, here abscissa is what? X axis, and ordinate is what? Y axis. Abscissa. So x axis can be called as abscissa and y axis can be called as ordinate. It's up to you. To represent any point, first we write its abscissa, then ordinate. Here, this is the rule. First we will have to write abscissa, then we will enter ordinate. First input, then output. Clear? First input, then output. In this way, we can mark the coordinate of points, and by combining them together, the geometric shape can be obtained. This is the basis element of a coordinate geometry. In order to solve our third situation problem, we will first mark the coordinates of J and Viru. Then the distance between those coordinates will be found out. In order to get the distance between the two coordinates, we will study distance problem. To find here we are taking coordinates, brother, not just a number. If we have two coordinates, then we can easily find the distance between them. Just we will have to use distance formula of a coordinate geometry. So distance formula of a coordinate geometry is something here. Okay, if you have two coordinates or more coordinates, then in that case you will have to use distance formula of a coordinate geometry. Clear? Now next, derivation of a distance formula. Here we have two coordinates, as you can see, this one, this one. At one point you will get one coordinate, and the second point you will get next coordinate. In this we have x1 comma y1. In this we have x2 comma y2. Here we are saying that x is here, this is much. Here let's say this is 1 and this is 2. So here we are saying that x1 is 1 and y2 is also 1 and this is 2. Let's say this is 2 and this is 3. Here we are saying that x is a 3, x is a 2 and y is a 3. That is what we are saying. That is how we are visualizing it. Now we will draw the perpendiculars from P and Q on x-axis. From P and Q on x-axis, this perpendicular. By this drawing perpendicular, we are able to visualize that yes, this is happening. This is what is it? It is the same. Here you can see what is happening. We are getting a Pythagoras triangle, right angle triangle. We are getting right angle triangle. This is forming base, this is forming perpendicular. This is forming base and one is it is forming perpendicular. Now we know that this is forming a right angle triangle. So here now we are able to use the Pythagoras theorem so that we can find this distance between this. This is distance is what this distance is what just hypotenuse, and we know that this distance, this is what just 1 centimeter, 1 unit, and this is what, this is how much, 1 centimeter, 1 centimeter. So both will give a hypotenuse which would be 2. Here remember we will subtract from here. So x2 minus x1, then we will get this left thing. Same here, y2 minus y1, then a square. Here y2 minus y2. Then we will do like that, y square minus y1. Then we will get this. Here you can see. That is how we will subtract. First x2 minus x1. It is giving this. And here y2 minus y1, it is giving this. If we apply Pythagoras theorem in triangle PQ2, then we can say that that this is a distance point, because in this we have a two coordinates. Let us again come to the problem of Jaya and Viru. Now it is easy for us to solve this problem. Yeah. Let's see here. It will form a right triangle. Just see here. Here, just to draw a perpendicular from this and from this. It will go like that and it will go like that. And just here you can see, here it will form a right triangle. Just to do as we did